Hello everybody. Okay, so now this is a new project. It's using a sensor to measure the distance. I'm using HC-SR04, similar to this. Okay, it's the same. This is SoundFounder, and that one it's just a non-SoundFounder. Okay, so this is the way it works. There is it will send an impulse, and when it bounces back, it will measure the distance, calculating the speed of sound. Okay, so I think the speed of sound is about 1,800 kilometers an hour, something like that. Okay, so one will be the trigger pin, and the other one will be the echo pin. So the one will send an impulse, and when it touches something, it will bounce back, calculating the distance, and let the rest of the project to know where it is. And this will be the distance, obviously, will be calculated and displayed on the LCD I2C. Okay, so I'm using I2C. It's SDA and SDA and ACL. So D1 and D2. D2 it's a SDA, and D1 it's a ACL. This is I2C. Okay, so you practically use two pins. Otherwise, you would have to use, like, let me show you. Without I2C, got a bit of dust, you would have to use something like this. lots of pins, and you can see there. Okay, let me see. Without I2C, you would have to use all these pins. Okay, because that's the way it is without I2C, which is a chip. Alright, so we'll make it easier instead of using all those pins. So the distance, it works, it will calculate over 100 centimeters. It will show when it's over 100 centimeter and or equal to 100 centimeter, it will show, let me see, it will show in meters. You see that, you can see. Okay, so if I go far away, I go over 4 meters. Okay, and if I get closer, you know, if I'm got too many objects, obviously, yeah, that's the way it works. So I'm sitting close now, so it's like some about half a meter. Okay, so there is some noise, electrical noise. So a suggestion is to use a capacitor. Okay, so we're going to use a capacitor to see if it stops the noise. And we put it here. Remember, the capacitor, the short leg goes to the negative, the ground, and the long legs go to the VCC, positive. Okay, so I'm going to perhaps put it here. Should switch off first. Let us see if the noise pollution that's actually worst. Yeah, that's yeah. Okay, seems to be a little bit better, but I will sort it out with another capacitor. I'll have to calculate the... Okay, so this is the way it's... Let me take it off. It's not really working. Okay, but you can put a capacitor, maybe a ceramic one. I will try and test later. Alright, so we got cover here, and as I said, here's the code. Okay, so there we have the code. You have, obviously you need wire.h, you don't need much here. And you're going to need the liquid crystal I2C.h, because it's an I2C, and I'll explain why. The I2C, I'll explain it. I think I wanted to show what the chip looked like. So I don't have a screen, extra screen. Okay, so but the chip, it's this one. Okay, so that's the chip. I'll show just now. Alright, so here we got, I've used the trigger pin on D5 and the echo pin on D6, okay. Then here you have your wire begin, D2, which is the I2C wire. It's SDA and SEL, okay. This one, LCD begin, it's 1602, because this screen is 1602. It's 16 block and it's got two. Let me show you. Or maybe the mouse problem. It's gone flat. Okay, so I'm gonna put some electrical on the mouse. Right. So where was I? Yeah. This is a way. 02 means 1, 2. There are two lines, and there's 16. There are 8 and 8. Okay. So that's the way it's called I2C, and it's 1602. It's the number of the screen. That's the name of the screen. Okay, so and there it is, LCD begin and so on. The pin mode, it's trigger pin is an output, and the echo pin is input. Okay, output. Trigger pin send the message, input receive, the echo pin receive the echo when it bounces back, and it tells you the distance. Okay, so the rest here, it's what digital, okay, the cross, digital, right, this is all the processing to have when to adjust when the pin is triggering and it's not triggering. Low means off, high means on. So when one is on, the other one is off, and send a message and receive a message. Okay, so this is a distance calculation, 0.034 divided by 2, divided calculated for centimeter. Okay, so the LCD will display 0.0, it's a first line, means distance. Okay, and then you have a 0.1, it's a second line, and we'll have the distance with the two integers, with the two integers, dot, two integers, okay? And I can show you here again. You will have this is line 01, and this is line 0. sorry, this is line 0, 0 and 0, 1. 0, it's a first line, and 1 is a second line. We will display the distance in text on the top and the centimeter and meters at the bottom with the number. This number is not a text number, it's a data which picks up from the trigger pin and echo pin. Okay, so it'll display the number here for the distance. Back to the card. All right, got everything, and here it will be, this is a second line which will display the distance centimeter, and it will be in cm. Okay, so the distance in centimeter will be printed but picked up by the HC-SR04. Okay, so and now here we have serial printed distance. If the distance is bigger or equal 100, the serial will print distance in centimeter divided by 100 and with two integers. Okay, and this serial will print the m, which is the meter. It will appear in meter instead of a centimeter. Or else, if it's less than 100, it will be in centimeter. Okay, so I think we covered everything here. I usually don't explain the card, and I really don't feel like to explain the card because I do this project in a way that I expect people, they already know, so they don't need to. As I said, I'm not teaching anything, I'm just bringing some new idea, although this doesn't look like a new idea, but yeah. Okay, I think we cover everything here. Yeah, that's it. Well, thank you very much. Please let me know if you like it. And thumbs up.